Fabulous Earth Science Faithful, video 7, right? Video 7, page 18 in our packet. It says up top, calculating earthquakes. So that's what we're going to do. So 1, calculate the time difference between the P wave and the S waves, arrival times. So you're going to write in arrival times. When I subtract time, times are listed as hours, minutes, seconds. You must have 2 digits for each. Okay. And then on the far left, remember 1 hour is 60 minutes and 1 minute is 60 seconds. This is not a perfect tens decimal issue. Okay. When I'm subtracting time. So there are notes. It says if we borrow an hour, we're really borrowing. That's what we get to. So the 1 hour equals 60 minutes. We're borrowing 60 minutes, remember. And if we borrow a minute, we're bringing over 60 seconds. But this is straight up seconds. So when I'm just subtracting, I'm only going to do the 1. When I do borrow a minute, though, that's what's tough. So on number 2, I should have done this too. So the 3 is just going to become a 2, like you know, because I'm only borrowing minutes here. And then that becomes a 1. This becomes a 3. Then 2 minus 1 is 1. And then 3 minus 2 is 2. Okay? Now I'm going to talk you through number 2 and see if you're paying attention or if you're bumping. Here, the 4 and the 0 I need to borrow from. So when I cross off the 3 and bring it to a 2, now I'm taking an hour into minutes, and now it's going to be 60 seconds. So I'm going to put a 6 where the 0 is, and a 0 on top of the 4. Then I have to borrow from the 6 to make it a 5. When I borrow from the 6, the 4 will go up to 14. So now I got 14 minus 6 is 8. 5 minus 5 is 0. 12 minus 8 is 4. So it should be 408. Okay? 408. So you do got to remember that you're subtracting 60 minutes. And I didn't put that in here so you could see it, talking you through it. So this is where you want to figure out the rest of these yourself, do some practice, check your work with my answer key before you move on to the next section, which is coming up here. So number 2, flipping the page. Oh, wait, there's just more. Page 19 is a whole bunch more of subtracting. What are your time differences? Then page 20 is just the reference table. And now we're already to page 21, which is not labeled. So how do we do this? How do we figure out the difference in time or the distance? So A, we're going to place a piece of paper along the travel time axis. We're going to mark the 2 edges of the paper, 0 and the time difference that I calculated. You'll see what I'm talking about. Then we're going to slide the paper between the P and the S waves, keeping the 0 on the P wave, and stop when the 2 marks touch both waves. Then read down to the epicenter distance. I'm going to do 3 of these for you right quick because there's a bunch of them for you to do at the bottom of the page. So this is what the bottom of your page looks like. This is what your reference table looks like. So this is how we do it. These are already calculated differences in time though. So we're just going to go ahead and take that 8 minutes and 20 seconds. I'm going to take my piece of paper, put it on, mark 0. I'm going to mark 8 minutes and 20 seconds. And then I'm going to slide this up until I get into both waves touching the marks that I made. Read down 6.6-ish kilometers. Perfect. 2 more quick, and then we'll be done with the video. 4 minutes and 30 seconds. Same process. Mark the 0. 4.5 minutes, 30 seconds is 4.5, so it's right in the middle. Bring that up until they both touch. Read down, almost to 3, just under 3. Good. One last one, and we donezo. 6-minute difference. Go to 0, go to 6. Bring it on up. Read down. Definitely less than 4.5, 4.35. There you go. Now we know how to calculate the distance to the epicenter using P and S waves. And there is another page of practice problems for you to work on. And we'll get into locating the epicenter next.